Okay, welcome to your next lab. It's a particle simulator, and the real goal of this is to get a lot of practice with array lists and writing for each loops. On the top left, you will notice that we have this set of binary numbers, all zeros, and this is just for your debugging. And you can turn these on and off by the Z through B keys on their bottom row of the keyboard. So Z will turn on the 1, the first position, the X turns on and off the second position, so it's just toggle. And we'll get to this a little bit later, but basically the Z key controls whether the alpha particles are impacted by gravity. The B key impacts whether the beta and gamma particles are impacted by gravity. The C key impacts whether the beta and gamma particles experience electromagnetic forces. Going to the right, the V key affects whether delta and epsilon have electromagic forces, and then finally the B key turns on and off nuclear family powers, and those will help in our debugging later. So to get started, you're going to be working with the number keys, and we have 5 different particles. Pressing 1s will add what are called alpha particles. Adding 2s are going to add beta particles. Adding 3s add gammas. 4 deltas, and 5 are epsilons. Just to show you what the simulation will look like, I'm going to add on all the forces, so I'll just turn them all on. And so you'll see kind of a little dance occurring here, and you'll notice that the yellows and purples kind of connect to themselves, but then kind of interact with each other, and you see things flipping around. So we're going to talk about how all those things individually work. For now, let's turn off the forces. So now all the flags are zeros. You'll notice that things are still moving, but they're not accelerating anymore. To clear different particles from the screen are the 6 through the 0 keys, and they just correspond to the 1 through 5. So 6, remove the alphas, 7 the betas, 8 I believe the gammas, and then 9 is deltas, and 0s are the epsilons. Okay, so now let's start seeing what the forces are. So at this point we've been able to add and remove particles. That's part A. Part B, you're going to need to create some array lists so that you can do part C. So in part C, if we add some alphas back in, and nothing's happening at this point, but if we then turn on the Z key, we'll see that they have gravity, and they're kind of pulled towards each other. So alphas attract alphas by gravity. If we then add in some betas, or some gammas, but I'll just add betas, I notice that nothing's impacting them yet, but now let's turn off these forces. So I'll turn off I hit the 0 key, so now no forces are occurring. If I press the X key, now beta will experience gravity towards the alphas, so that you'll notice that the alphas are not being impacted by the betas, but the betas are being impacted by the alphas. And so they kind of chase the alphas around, and when they get too close, they super accelerate and fly away. The same is true with gammas, so if I add some gammas in, they will also chase the red ones. Turning off those forces, so now there's no forces again. Beta and gamma also experience electromagic forces, where they're attracted to the other kind, so greens are attracted to blue and blue is attracted to green, but then green repels green and blue repels blue. So I'll turn that on, pressing C, and we'll notice now that the greens push each other away, but they're pulled towards the blues, and same thing for blues. So blues push away blues but are attracted to greens. Now all these forces have been implemented for you in a set of functions in particle. Your only job is to call them appropriately using the walking through your list of particles in array lists. Our last set of forces involve delta and epsilon, so let's clear what we have here, and let's add in a bunch of deltas, and sure, let's add in some epsilons as well. They have 2 different types of forces. Let's do the last force first, so it's the B key. This is the nuclear family, and let's add in some more. So the yellows kind of want to be next to yellows, and purples want to be next to purples, and they kind of have the center of an atom feel. So that's pulling together. But then if we add on the electromagic, which I'm going to hit the V for, now the yellow repels yellow in one way, but then has a nuclear family, so kind of a little bit of a dance. And then yellow attracts purple in general, and purple attracts yellow. So then if we add them all in, I'll turn on all the forces, and we add in a bunch of different particles, you'll see like a little dance going on. And they're all interacting with those different types of forces. So that gets you through parts 1 through C. And then part D is just going down the QWERTY line of your keyboard, just forcing you to do some arrayless things. And let's turn off all the forces at this point so we can just watch what's going on. Whenever we hit Q, it just removes a random alpha. W is similar, but it doesn't remove a random beta, it just removes the most recently created, and you can just keep hitting it until there are no betas left. Same thing for hitting Q. I'll hit Q again, and you keep hitting it until there are no alphas left. And if you hit it extra, it won't hurt anything. E does something similar where it removes the third oldest gamma, and then once there are 2 left, it doesn't add anymore because there's no more third oldest. R will remove the fastest delta, so you'll have to look for the velocity. Again, you can call it multiple times. T will change the number of delta particles to match the number of epsilon particles and just add them arbitrarily around the screen. So now the purple ones match the number of yellow ones. And finally, if you hit Y, you'll change all the epsilons into deltas. So now all we have is deltas. And that's it. That's the whole lab. Then export it and submit it.